we know how many El Nino events happened in the past. Okay, how often do we get El Nino events? Okay, so how can we reconstruct El Nino events from the past? And this is all about developing a climate index. It's about climate indices. For the El Nino Southern Oscillation, you actually have two options. Okay, two options to reconstruct past ENSO events. And so one option is you can look at weather data. Okay. And the idea is, so if you, for example, you look at the pressure difference between Tahiti and Darwin, okay, so you have weather stations here, which are shown on this map. And with a little bit of background, you can actually work out that near the equator, where there is no Coriolis force, the easterlies or westerlies, the trade winds or their reversal, can be actually inferred from a zonal pressure difference. Okay, and this is what we call the Southern Oscillation Index. Okay, it's defined as the air pressure difference at sea level between Tahiti and Darwin. Okay, and from that, you can actually identify the wind reversals that you get during the onset of an El Nino. So what you also can do is you can look at sea surface temperature data. Okay, we do that in a second. So why do you look at use weather data? Or because you have, in some instances, more than 150 years of data. Yes, you have a relatively long observation time span. Okay, so now sea surface temperature. So you don't have a long time span for that, because it's probably 30 years old, this satellite technology. Okay. So, but what you can do is you can look at sea surface temperature anomalies, like in the movie that I showed. And you can specify specific regions. And this is shown on this map here on the right. So what scientists have done is they look at the region from 5 degrees south to 5 degrees north, and they define different regions. One is called Niño 4, one is called Niño 3, and there's also an area more linked to the Peru upwelling system called Niño 1.2. But what turns out to be the best is just a mixture between Niño 4 and Niño 3, and this region is called Niño 3.4. Okay? So now I'll show you how it looks like. So let me just click through here. Oh, yeah, here we go. I'm almost there. Yes, come on, yes. And this is how the time series of these two indices look like. These are time series from 1982 to 2000 and something like around 2010. Yep. You can see the SOI, Southern Oscillation Index, at the top. See that it changes from negative values to positive. Okay, you can also look at the Niño 3.4 index, which is shown here at the bottom. Okay. And again, positive anomalies, which reflect El Nino events, are shown as red regions, and negative are shown as that's La Nina events are shown in blue. And you can see there's a one-to-one correspondence. Okay, so the SOI and Niño 3.4 essentially show you the same feature. And again, this illustrates the coupling between the atmosphere and the. Okay. And another thing that you learn is that, okay, so how often do you get El Nino events? Oh, it changes. You can have an El Nino events. Well, sometimes it's 5 years between El Nino events. Sometimes it's a little bit shorter. So say between every 2 to 5 years you get an El Nino event. However, it's impossible to predict El Nino or La Nina events for that purpose. Okay, yeah, it's you probably can do it with the lead time if it just started, okay, or if it's almost there. So with a lead time of say 3 months or so, but for a lead time of 1 year ahead, it's impossible to do that. And you could earn millions if you could. Okay? All right, so this is the El Nino Southern Oscillation.